each mineral has a unique set of properties that we can use to identify it. And if you are in the lab for this course, you are going to get very well acquainted with these mineral properties. But this is going to be a quick introduction and probably the only little bit of mineral properties the people who are not in lab are going to get. So the first mineral property that we can look for to identify a mineral is its luster. This just means, how shiny is it? Is it shiny like a metal that it has a metallic luster? Or is it kind of dull, earthy? It doesn't look like a metal. Then we call that a non-metallic luster. We can also measure its hardness, right? So we use what we call the Mohs hardness scale to figure out, is it incredibly hard, like almost nothing else can scratch it? Then maybe it's diamond. Or is it super, super soft? So soft we can scratch it with our fingernail. Then it might be gypsum or talc. Next up is color, and I know that it's so easy to look at a mineral and the very first thing you see is color and you want to use color to identify it. Please don't. Color is actually the worst way to identify a mineral, and that's because minerals can be so many different colors naturally. So for example, quartz, we often think of it as clear, and it's often clear, but it can also be green and orange and purple and pink and blue and gray and black. It can be all sorts of different colors, right? So yes, we can use color to identify minerals. It should never be your first option, right? Please don't use color until you've gotten a lot of practice with these minerals. What can be more important though is the streak. So often the color of the mineral doesn't help you that much, but the color of its streak can. And by streak, I mean, if you were to take that mineral and scratch it on something else so that the mineral leaves behind a tiny little like trail of powder, pulverized powder, the color of that streak can give you a lot of information. So for example, the mineral hematite can be a variety of colors. It's most often dark, like a dark gray, a dark black, a dark red. But no matter what color it is, when you just hold it in your hand, when you streak it, the streak is always going to be like a reddish, brownish, rusty color. Next up is form or habit. This really just means shape of the crystals. Some crystals form in cubic shapes like halite. Some of them form in these long prisms such as quartz. Right? Lots of crystals have many different crystal shapes or habits. Next up, cleavage. I think this is one of the most important ways to identify minerals, even though it can be kind of difficult when you're first starting out. And this just means, how does the mineral break, right? So for example, let's take a little cube of halite, a little cube of salt. If you were to take a hammer and smash that cube of salt, you would notice that that cube of salt just breaks up into smaller and smaller cubes, right? But it keeps its shape. When minerals do this, when minerals have a defined shape, that when they break, they keep that shape because they break along these defined clear planes. We call that having cleavage. So halite has a cubic cleavage. Now, other minerals don't have any cleavage at all. This means that when you break them, it doesn't break into a defined shape. It's just totally random, kind of like glass. It just shatters. This is like quartz. Right? So if I were to break quartz, who knows what shape it would go into, right? It'd be totally random. And this is actually how I tell the difference between quartz and fluorite. They can look very, very similar in almost every way other than how they break. Quartz fractures randomly, whereas fluorite has cleavage, and it actually like forms these little like pyramid triangular shapes. Next up, many minerals fluoresce when exposed to UV light, like a black light. If you've ever been to a museum and they have a mineral room, often in the back corner, you'll be able to go into this dark room and they'll turn on the black lights, and it's almost like you're in like a 70s trip, right? Like minerals can have such cool fluorescence. For example, sulfur glows bright yellow under a UV light. There's lots of other properties that we use that I'll just quickly go through, like odor. Sulfur smells like rotten eggs. It's why the water in Brunswick doesn't taste very good. Taste, halite, for example, tastes salty. It's salt, right? So we won't do this in the lab, but if you're ever out in the real world and you ask me to identify a mineral, I'm probably going to stick it to my tongue. Magnetism is another one. A lot of these minerals are magnetic. For example, magnetite, so creatively named, is magnetic. Many of them can react when exposed to acid. So if you ever give me a specimen and you say, I don't know what this is, I think it's calcite, but I'm not sure, I'm going to say, well, drop some acid on it, right? If it fizzes, if it reacts, it's calcite. If it doesn't, it's something else. Some minerals can also have little striations. It kind of looks like little scratches, little grooves on the surface. For example, pyrite, also called fool's gold, has these striations on its surface.